Picture this. You're standing in a cramped, smoky workshop in medieval Europe, and the sound of hammers striking metal echoes through stone walls like a deadly percussion concert. But these aren't blacksmiths making horseshoes or weapons. These craftsmen are creating something far more valuable than swords or armor. They're literally making money. Welcome to the fascinating world of medieval coin minting, where silver bullion gets transformed into the currency that built empires. Most people think coins just magically appeared in medieval times, like someone waved a wand and suddenly there was money everywhere. Wrong. The process of turning raw silver into spendable coins was more complex than performing surgery with a butter knife. Every single coin in your ancestor's pocket was hammered by hand, shaped by skill, and required more precision than threading a needle during an earthquake. The year is around 1250, and we're about to dive deep into one of history's most crucial yet overlooked industries. Before we start hammering away at this topic, make sure to hit that subscribe button and give this video a like. And hey, drop a comment about what you find most interesting, whether it's the medieval craftsmanship, the sheer amount of work that went into each coin, or maybe you're just amazed that people figured this stuff out 700 years ago. Your engagement helps us keep digging into these incredible historical processes that shaped our world. The whole coin-making adventure started with something that looked more like a chemistry experiment than a mint. Raw silver bullion arrived at the workshop looking like rough chunks of metal that had seen better days. But these weren't just any old silver lumps, they were the foundation of an entire economy. The first challenge was figuring out exactly how pure this silver actually was, and medieval minters had some surprisingly clever tricks up their sleeves. Enter the touchstone test, which sounds way more mystical than it actually was. Picture a dark stone surface where craftsmen would scratch the silver bullion, creating a streak of metal. Then came the real magic. They'd apply nitric acid to that streak and watch what happened. Pure silver would barely react, while impure silver would bubble and change color like a science fair volcano. The color and reaction told them everything they needed to know about the silver's purity. It was like having a medieval lie detector test, except instead of catching criminals, they were catching bad silver. But the touchstone was just the warm-up act. When they really needed to know the exact purity, they brought out the big guns, cupellation. This process involved heating the silver in a special clay cup called a cupel until it glowed like a tiny sun. Any lead or other base metals would oxidize and get absorbed into the clay, leaving behind pure silver that gleamed like moonlight. The whole process required temperatures hot enough to melt silver. That's over 1,700 degrees Fahrenheit. These medieval craftsmen were basically playing with molten metal using nothing but clay cups and charcoal fires. Here's where things get really interesting, and kind of nerve-wracking if you think about it. Medieval coins weren't made from pure silver, because pure silver is softer than a marshmallow that's been sitting in the sun. Instead, minters had to create the perfect alloy, mixing their purified silver with just the right amount of copper to make coins that wouldn't bend every time someone looked at them funny. The standard mixture was usually around 92% silver and 8% copper, though this varied depending on which kingdom you were in and how honest their rulers were feeling that decade. Getting this mixture right was crucial because the entire economy depended on people trusting their coins. Too much copper, and your currency would be worth about as much as a wooden nickel. Too little, and your coins would be so soft that merchants could literally bend them with their fingers. One miscalculation could tank an entire kingdom's monetary system faster than a bad harvest could cause a famine. Once they had their perfect silver alloy, the real work began. The molten metal got poured into molds to create narrow ingots that looked like silver candy bars. Except eating these would definitely not give you a sugar rush. These ingots were the raw material that would eventually become hundreds of individual coins. But first, they had to go through a transformation that would make any modern manufacturing engineer weep with admiration. The smiths took these silver ingots and began the backbreaking process of turning them into thin, flat sheets. Using nothing but hammers and anvils, they'd pound and roll the metal until it was thin enough to work with, but strong enough not to fall apart. This wasn't gentle work. It required serious muscle and incredible precision. One wrong strike, and you could ruin an entire batch of expensive silver. The hammering created so much noise that these workshops probably violated every noise ordinance that would exist if noise ordinances had been invented yet. But here's the clever part that shows just how sophisticated these medieval craftsmen were. They knew that all that hammering made the silver hard and brittle, so they'd periodically heat the metal strips in a process called annealing, which basically gave the silver a spa day. The heat relaxed the metal's internal structure, making it soft and workable again. It was like giving the silver a massage so it wouldn't crack under pressure. From these carefully prepared sheets, workers would punch out individual blanks, the circular pieces that would become coins. This required punches sharp enough to cut cleanly through silver, but strong enough not to break after hundreds of strikes. Each blank had to be perfectly round, or as close to perfect as you could get when everything was done by hand. The waste from this process wasn't thrown away, though. Every silver scrap was saved because, well, it was silver. In medieval times, wasting precious metal was like throwing away your retirement fund. Now came the most critical part of the entire operation, making sure every single blank met the exact weight requirements. This wasn't just about being picky. The weight of coins determined their value, and people took this stuff seriously. Each blank got weighed on scales so sensitive they could detect differences smaller than a grain of rice. If a blank was too heavy, craftsmen would carefully file away tiny amounts of silver until it hit the target weight. Too light? Well, that blank would probably get tossed back into the melting pot to start the whole process over again. The attention to detail was absolutely insane by modern standards. We're talking about medieval craftsmen achieving precision that would impress modern manufacturers, using nothing but hand tools and centuries of accumulated knowledge. Every blank had to be within a tiny fraction of the correct weight, or the entire monetary system could collapse faster than a house of cards in a hurricane. But weight wasn't the only concern. The surface of each blank had to be pristine, which is where acid blanching came into play. The blanks would get a quick acid bath that cleaned away any oxidation or discoloration, leaving behind bright, clean silver that looked worthy of bearing a king's image. This acid treatment was like giving each future coin a power wash before its big photo shoot. The real artistry began with the creation of the dies, the metal stamps that would imprint designs onto each blank. Master engravers would spend days or even weeks creating these intricate tools, carving backwards images into hardened steel with a precision that would make modern laser engraving look sloppy. The master engravers were basically medieval artists working in reverse, and they had to be absolutely perfect. Every line, every letter, every detail of the ruler's face had to be carved as a mirror image, because once that die hit the blank, there was no going back. One tiny mistake in the engraving meant starting over from scratch with a fresh piece of steel. These craftsmen could spend weeks perfecting a single die, and their work would determine whether coins looked magnificent or like they'd been designed by someone wearing a blindfold. The engraving process itself was a masterclass in patience and precision. Using tiny chisels and gravers, the engraver would slowly carve away steel, constantly checking their work against drawings or existing coins. The ruler's portrait had to be recognizable, but also fit within the tiny space of a coin face. Meanwhile, the lettering around the edge, called the legend, had to be perfectly spaced and readable. Remember, these dies would be used to strike thousands of coins, so every detail had to be absolutely perfect from day one. What made this even more challenging was that medieval rulers had some pretty specific ideas about how they wanted to appear on their money. Kings wanted to look powerful and divine. So engravers had to make sure every coin portrayed them as the magnificent rulers they believed themselves to be. This meant countless revisions, royal approval processes, and probably more than a few engravers pulling their hair out trying to make King so-and-so look heroic on a piece of metal smaller than a modern quarter. Once the dies were complete, the real magic happened on the workshop floor. This is where raw silver blanks transformed into actual money through a process that was part craftsmanship, part athletic performance, and part carefully choreographed dance. The striking team worked with military precision because speed and accuracy meant the difference between profit and disaster. The setup was deceptively simple, but required incredible skill to execute properly. The bottom die, called the pile, was mounted securely in an anvil or wooden block. This die contained the design for one side of the coin, usually the ruler's portrait or the main symbol of authority. The pile had to be perfectly stable because any wobbling would ruin the strike and waste precious silver. On top of the blank went the upper die, called the trussel, which carried the reverse design, often a cross, coat of arms, or religious symbol. The trussel was held in place by hand, which meant the worker holding it needed nerves of steel and reflexes like a cat. One wrong move and they'd either miss the blank entirely or get their fingers smashed by a hammer moving fast enough to dent metal. The hammer work itself was an art form that took years to master. The striker had to deliver one or two clean, powerful blows with enough force to imprint the design clearly into the silver, but not so much force that the blank would crack or the dies would break. Too gentle, and you'd get a coin with a barely visible design that looked like someone had sneezed on it. Too hard, and you'd destroy everything. The blank, the dies, and probably someone's hand in the process. Without modern collar systems to contain the metal during striking, keeping the dies centered on the blank required steady hands and perfect timing. The blank would want to shift or jump during the impact, so the die holder had to keep everything aligned while a hammer came crashing down inches from their fingers. It was like playing the world's most dangerous game of whack-a-mole, except missing meant ruining expensive silver and possibly losing a finger. The speed at which experienced teams could work was absolutely incredible. A skilled striking crew could produce several hundred coins per hour when everything was running smoothly. That's a finished coin every few seconds, each one requiring perfect coordination between multiple people, working with deadly tools around molten metal and flying hammers. Modern assembly lines would be impressed by this level of efficiency, achieved with nothing but human skill and medieval technology. But not every strike was perfect, and that's where quality control became crucial. Freshly struck coins would be tipped into collection trays where they'd get their first inspection. Coins with clear, complete designs and proper weight went into the good pile. Anything with blurred images, incomplete strikes, or other defects got tossed back into the recycle bin to be melted down and start the whole process over again. The inspection process was thorough enough to make modern quality control departments jealous. Every coin got checked for design clarity, proper weight, and correct dimensions. Remember, people's livelihoods depended on trusting these coins, so anything less than perfect could undermine the entire monetary system. A batch of bad coins could destroy a kingdom's reputation faster than losing a war. Counting and weighing happened in batches, with oversight clerks recording every detail in ledgers that would make modern accountants weep with envy. These records tracked not just how many coins were produced, but their total weight, the fineness of the silver used, and which specific moneyer was responsible for each batch. This wasn't just bookkeeping. It was a complete audit trail that could trace any coin back to the exact day it was made and who made it. The bagging and sealing process was like preparing treasure for shipment, because that's essentially what it was. Finished coins were counted into specific amounts, placed in sealed bags, and marked with official stamps that guaranteed their authenticity and weight. Breaking these seals without authorization was probably a crime punishable by something unpleasant involving sharp objects and public humiliation. The mathematical precision behind this entire operation would blow your mind. A typical mint in 1250 could process about 200 pounds of silver per day when running at full capacity. That translates to roughly 15,000 individual coins, each one requiring multiple quality checks and precise measurements. The waste rate was surprisingly low. Skilled crews only lost about 3% of their silver to trimming, misstrikes, and other mistakes. That level of efficiency would make modern manufacturers jealous, especially considering they were working with hand tools and open flames. But here's where things get really fascinating: the economics of the whole operation. The mint didn't just randomly decide how many coins to make each day. Production was carefully calculated based on demand, available silver, and something called the mint's account with the royal treasury. Every ounce of silver that came in had to be accounted for, and every finished coin had to match the records exactly. One missing coin could trigger investigations that would make modern audits look like casual paperwork reviews. The oversight clerks were basically medieval forensic accountants. They tracked everything: when silver arrived, how pure it was, how much was lost during processing, how many coins were produced, and where every finished batch went. Their ledgers were more detailed than most modern business records. These guys could tell you exactly how much silver was used to make coin number 4,147 on Tuesday, March 15th, and who was working the hammer that day. The moneyer himself, the guy officially responsible for the entire operation, had his reputation and probably his life on the line with every batch. Medieval kings took their currency seriously, and getting caught skimming silver or producing underweight coins was a career-ending move in the most literal sense possible. The moneyer had to guarantee that every sealed bag contained exactly what the label claimed, down to fractions of an ounce. Quality control extended beyond just individual coins. Batches were regularly tested by melting down random samples to verify their silver content. Imagine being the guy whose job was to destroy perfectly good money just to make sure it was made correctly. They'd take a handful of coins from each batch, melt them back into silver, and run the same purity tests they'd used on the original bullion. If the finished coins didn't match the expected purity levels, the entire batch would be rejected, and the moneyer would have some serious explaining to do. The workshop itself was designed like a fortress, and for good reason. With hundreds of pounds of silver being processed daily, security was tighter than a royal treasury. Armed guards watched every entrance, and workers were searched coming and going. The temptation to pocket a few silver scraps must have been enormous, but the consequences of getting caught made it a gamble most people weren't willing to take. Storage of finished coins created its own set of challenges. Thousands of freshly minted coins couldn't just sit around in baskets waiting for pickup. They needed secure storage that protected them from theft, moisture, and damage. Special strongrooms with multiple locks housed the sealed bags until they could be transported to their final destinations. These storage areas were basically medieval bank vaults, complete with guards and elaborate security procedures. The transportation of finished coins was an adventure all by itself. Sealed bags of silver coins were incredibly heavy. A bag containing just 1,000 coins could weigh over 50 pounds. Moving large quantities required wagons, armed escorts, and carefully planned routes to avoid bandits who knew exactly what those heavy bags contained. Highway robbery wasn't just a movie concept. It was a legitimate business risk that mints had to factor into their operations. Weather played a bigger role than you might expect. Rain could ruin the charcoal fires needed for melting and annealing. High humidity made the delicate weighing scales less accurate. Cold weather made the silver harder to work with, while extreme heat made the working conditions nearly unbearable. Medieval mints had to plan their production schedules around weather patterns, just like farmers planned their harvests. The human cost of this precision was enormous. Workers developed specific injuries from their repetitive tasks. Hammerers got shoulder and arm problems from the constant striking. File workers developed respiratory issues from breathing metal dust all day. Scale operators suffered eye strain from constantly checking tiny weight differences. Yet these craftsmen took pride in their work that bordered on obsession. They were literally making the money that kept kingdoms running. Training new workers was a years-long process that made modern apprenticeships look like weekend workshops. A new hire might spend 6 months just learning to file blanks to the correct weight before they were trusted with more complex tasks. Master engravers were so valuable that they often worked under exclusive contracts that prevented them from taking their skills to competing mints. Losing a master engraver to a rival kingdom was considered an economic disaster. The social status of mint workers was surprisingly high for medieval craftsmen. They were essential to the kingdom's economy, which gave them job security and respect that most trades couldn't match. The master moneyer was often a wealthy and influential figure in the community, rubbing shoulders with merchants and minor nobility. Even regular mint workers earned better wages than most other craftsmen because their skills were so specialized and crucial. Seasonal variations affected production in ways that would surprise modern manufacturers. Spring brought fresh silver from mines that had been shut down during winter. Summer's longer daylight hours allowed for extended work shifts. Fall was harvest time for silver production, as mints rushed to create enough coins for the harvest season's increased trade. Winter brought challenges, but also opportunities. The cold weather made it easier to achieve precise measurements, and reduced trade meant more time for maintenance and preparation. The mint's relationship with local merchants was complex and fascinating. Merchants needed coins for trade, but they also brought foreign coins that needed to be evaluated, melted down, and recoined. This created a constant flow of silver through the mint that had to be carefully tracked and accounted for. Some merchants became regular suppliers of raw silver, while others specialized in distributing finished coins to distant markets. International competition between mints was fierce and sometimes led to what we might call medieval currency wars. Kingdoms would try to make their coins slightly more pure or more precisely made than their neighbors' currencies. Merchants would prefer coins from mints with better reputations, which could affect entire kingdoms' trade relationships. A mint's reputation for quality and honesty was literally worth its weight in silver. The techniques developed in medieval mints didn't disappear when mechanization arrived. They evolved. Many of the quality control methods, alloy formulas, and precision techniques used in 1250 continued to influence coin production for centuries. Some of the mathematical ratios for silver purity that medieval moneyers perfected are still used in modern precious metal working. The attention to detail and systematic approach to production that kept medieval currencies stable laid the groundwork for modern manufacturing quality control systems that we still use today. The record-keeping systems that tracked every ounce of silver were more sophisticated than most people realize. Each mint maintained what they called the assay register, a detailed log that recorded the purity test results for every batch of silver that came through their doors. These weren't casual notes scribbled on scraps of parchment. We're talking about official documents with multiple signatures, wax seals, and enough legal weight to hang someone if the numbers didn't add up. But here's where things get really wild. Medieval mints basically invented the world's first recycling program. Except, instead of saving the environment, they were saving their own necks from bankruptcy. Every tiny scrap of silver that got filed off blanks, every failed coin that didn't meet standards, every bit of metal shaving from the cutting process, it all went back into the melting pot. Nothing was wasted, because wasting silver was like throwing away your house payment. The recycling process itself was an art form. Workers would collect the silver dust and filings in special leather aprons that got turned inside out at the end of each shift. Even the sweepings from the workshop floor were saved and sifted for silver particles. One account from a London mint in 1275 mentions recovering over 20 pounds of usable silver just from what modern workers would have thrown in the trash. Temperature control became an obsession that would make modern engineers jealous. The difference between silver that was perfectly workable and silver that was either too brittle or too soft came down to heating it to exactly the right temperature and cooling it at precisely the right speed. Medieval smiths developed techniques for judging metal temperature by color that were accurate to within about 50 degrees. Pretty impressive for people working by firelight with no thermometers. The charcoal used for heating wasn't just any old wood that someone threw in a fire. Different types of wood produced charcoal with different burning characteristics. Oak charcoal burned hot and steady, perfect for melting operations. Willow charcoal burned cleaner, making it ideal for the delicate annealing process. Some mints maintained their own forests specifically to ensure they had the right types of charcoal for different stages of production. Quality control extended to tools in ways that would surprise most people. The hammers used for striking weren't just heavy lumps of metal. They were carefully balanced, with specific weight distributions that affected how cleanly they struck the dies. A hammer that was even slightly off balance could produce coins with uneven impressions or damage the expensive dies. Master hammerers often had their tools custom made and would guard them more carefully than most people protected their life savings. The dies themselves required maintenance that was basically medieval precision engineering. After striking several hundred coins, the fine details in the engraving would start to wear down. Die maintenance specialists would carefully recut worn areas using techniques that matched the original engraving so perfectly that you couldn't tell where the original work ended and the repair began. A well-maintained die could produce thousands of coins before needing replacement. Worker specialization reached levels that would make modern assembly lines look simple. Beyond the obvious roles like hammerer and die holder, there were specialists whose entire job was adjusting the weight of blanks. These filing experts could remove precise amounts of silver, sometimes just a few grains, to bring underweight blanks up to standard. The best filers could work so precisely that their adjusted blanks were often more accurate than machine-cut blanks from centuries later. The math behind daily production was staggering when you really break it down. A typical mint needed about 15 minutes to process 1 pound of silver from raw bullion to finished coins. That included all the testing, alloying, rolling, cutting, weighing, adjusting, striking, and final inspection. When you consider that they were doing this with hand tools and open fires, achieving that level of efficiency was like performing magic tricks with metal. Timing coordination between different workstations became crucial for maintaining efficiency. The melting crew had to finish preparing silver alloy, just as the rolling team finished their previous batch. The blank cutting team needed to stay ahead of the striking crews, but not so far ahead that blanks sat around collecting dust or getting mixed up. One bottleneck anywhere in the process could slow down the entire operation and cost the mint serious money. Medieval coin minting was basically the world's first precision manufacturing operation, run by people who could achieve modern accuracy using nothing but hammers, fire, and centuries of accumulated knowledge. These craftsmen turned raw silver into the backbone of entire economies, one carefully weighted coin at a time. The next time you flip a coin, remember that somewhere in its DNA are techniques perfected by medieval workers who literally hammered out the foundations of modern commerce.